Hello, everyone. I'm Maarten Witteveen, co-founder CTO at MANUS. And I've been talking about, well, first of all, thank you, G-Ben, for already making or giving a great introduction. So I'll be talking about how do hands integrate into this Isaac Sim setup. So MANUS, where human motion becomes machine skill. So at MANUS, we make data gloves to track human movement to be deployed for robotics training, either through telepresence, virtual telepresence, or egocentric data capture. So first, before diving into how the integration works, I want to give a little rundown for people that are not familiar with what MANUS does and what we are as a company. So one of the unique things is that we use electromagnetic field tracking for our sensors. It's a proprietary technology that we developed ourselves, and that allows for really accurate endpoint positioning. So you can imagine it as absolutely determining where the endpoints are of the finger, and that allows for that really accurate direction, especially on the end effectors that are the most important for robotics placement. It works fully occlusion-free, so that's definitely for, if you're used to using the Quest 3 or the Pico 4, the hand tracking, it can be very easy to do self-occlusion. So when you're looking through the viewpoint of the Quest 3, like, you'll lose a lot of data, or doing hand-to-hand interaction. With our EMF technology, that is no longer the case, so you get really accurate tracking in that sense. Then everything is live streamed, you can do it recording, and we're all known for bringing that new innovation into the market. So we'll also be working on pressure sensors, haptic technologies, and everything needed to bring this out at scale into these systems. Then onto the product. So how MANUS categorizes itself is we want to make products that operators can wear for 8-hour sessions, 20-hour sessions, doesn't matter. Everything is lightweight, everything's durable, everything breathes, feels comfortable. So that makes it unique in that sense, that a pilot can wear this for really extended sessions and just have a good experience. Everything is modular and serviceable, so top casings can be removed, batteries can be removed, everything can be done to make sure that you have like clear sessions and everything is modular and serviceable. And to make it clear, like, everything is now out for production. You can just have this deployed at scale, and customers are also deploying this at scale. Then, as a company, like MANUS already exists for 12 years. We actually started as a company into the VR industry. That's our roots. So it's really nice to, through this Isaac Sim interface, go back to those roots and use all the knowledge that we built up over the years on how to interface into the virtual space and how to bring spatial interaction into those spaces. So we do that for digital twins, but we also do that for life science and the entertainment industry. But the predominant market and what we're here for is, of course, the robotics space. And we do that with like the highest quality. Like, that's what we're known for, like bringing the best data quality into those markets. Then on to our latest release. So this is the haptics version of the glove as well, which features LRA, linear resonant actuators, vibrotactile feedback on each of the fingers, so per finger haptic feedback. And it provides that full 25 degrees of freedom tracking, fully occlusion-free, ready and available into the Isaac Sim pipeline, fully set up. And then, of course, what does that look like? So here we have set up the haptics version of our glove into the Isaac Sim pipeline, fully retargeted. This is actually now using the computer vision tracking of the Quest 3. It can also work with the tracked controllers to provide the spatial tracking. so really intuitive, free form, can operate into those virtual spaces, really dexterous manipulation tasks, allowing that to be used. So on a high level, what does that look like in terms of integrating? So on the left top side, you have our Medicals Pro Haptic, providing the finger tracking, like the full 25 degrees freedom, skeleton data information. Then on the right, you have the coordinates coming from the head-mounted display to provide the absolute positioning in relative space to the user. That goes through the Cloud XR layer into the Teleop for Isaac Lab. And there's a crosstalk between our SDK, like we have a layer fully set up in a C++ SDK. And that is like co-installed with the Isaac Sim setup. And that's also where the information, also for the future, for haptics information to flow back towards our gloves. The Isaac part is, in Isaac Sim, the haptics part is coming in Q2. So not available right now. The product is available, but the integration into Isaac Sim, that will come in Q2. And that, of course, it flows through Isaac Lab into the data collection pipeline for the deployment at the customer site. Then onto the installation. So we've made this really simple to get started. So the plugin is available. And you basically have two options during the install. So you can just do the integrated version, which if you're using a Linux machine, you just run the integration, or the core integrated version, like on the top. If you want to set it up with a Windows PC in there, like we've also have an option to go from Windows PC and stream it out to a Linux PC, and then you would need the bottom option. But most robotics customers, like they want to use directly onto the Linux machine, so you select one there, and then it just runs the installation. Then we've made a step in between where you can verify, because of course, you're connecting a lot of hardware together, so you want to make sure that everything is operational before diving into your simulation. So this is a checking step you can do before, so you can have in a console window, check if all the glove data is coming in. So to ensure that the dongle is inserted, the gloves are turned on, everything is operational, and you're getting finger data to be utilized. Then in terms of hardware, like how do you put this together? As I said, you can utilize the optical tracking from the Quest 3 or the Pico 4, but you can also use our adapters to attach the controller there, hook up the controllers, slide it into the glove, and have that fully up and running. Then, of course, onto the use. So you can run the plugin through the Cloud XR layer through this install. And then have that through the retargeter that's already set up. Like we use an open source retargeter to get that hand data that's fully calibrated and scaled to the user hand, retarget that towards the robotic hand. We've tested this out with the like the Inspire hands, also with the Sharpa hands. So it's a really nice way if you're deploying for a new robotic system and you don't have the physical robot there to run the simulation and test everything out, or try out different vendors and see if your operation works like you're intended to. That's the nice thing about the digital twin type of setup, that you can already test your whole factory line into simulation even before deploying it. And the nice thing is also with the light wheel assets is that you can have all those models in there, do the full factory line setup. Just a very nice way to run everything very cost-effective into simulation. Then, of course, onto why use gloves. So the nice thing is about that there's no occlusions happening. And that's something that if you're used to running into a VR environment, it's really easy to self-occlude the fingers. And it's very clever, or I would say very advanced, how those vision systems try to accommodate and resolve for the hand, even when they can't see every single bone, like the machine learning algorithms working there to resolve for it. But it's not the exact position, and especially if you're doing interactions like pinches and grabs, you'll see that is still like lacking in that sense. So if you want that high fidelity, then you definitely want to use gloves in there. It also provides the haptics interface so that when you're colliding with an object, you can feel that that collision happens, and it gives good cues for the pilot or when you're running into that environment to know, am I touching the object, am I grabbing the object, did I release it correctly? Those cues so that you can, with confidence, navigate those virtual spaces. And of course, like the overall accuracy is higher than using only track controllers or the optical tracking. Then we have a nice offsite setup. So if you would like to see this demo running, we have it available at the Spaces, which is just, it says 40 minutes, but you can easily do it in 10. So if you want to meet up, try it out, test the Isaac Sim setup, we also have the Sharper Hand setup. So feel free to come by and check it out.